Welcome to another video. In this video, we are going to solve integral sin 2x over a cos² x plus b sin² x dx. To convert this complex denominator to simple form, we can give a substitution. We can substitute t as a cos² x plus b sin² x. Then differentiation with respect to x. Differentiation of the t we can write as dt over dx. Differentiation of the a cos² x we can write a into 2 cos to the power of 1x into minus sin x. Differentiation of the b sin² x we can write b into 2 sin x into cos x. Now we can get 2 sin x cos x as a common factor. Then we can cross multiply dx and we can subject dt value. Then we can subject dx as dt over 2 sin x cos x into b minus x. Let's move to integration part. Integral, instead of sin 2x we can use double angle formula of sin 2 theta. Sin 2x we can write as 2 sin x cos x. Instead of denominator value we can write t. Instead of dx value we can write dt over 2 sin x cos x into b minus a. Now we can cancel out 2 sin x cos x denominator and numerator terms. Then we can get 1 over b minus a as a constant value from integration part. Then integral 1 over t. We know integral 1 over t we can write as ln modulus t. We know t equal a cos² x plus b sin² x. So we can get final answer as 1 over b minus a into ln modulus a cos² x plus b sin² x plus c. Here c is an arbitrary constant.